Okay, it has been a while, but I had some requests to make a review video for you guys before you took your Chapter 6 test. So it's going to be short, sweet, and to the point. So the first thing that we are asked to do here is to tell whether it is exponential growth or decay. So we notice that when we have a base that is a number like this, we look at it and say, how do we know if it is growth or decay? Well, if it is between 0 and 1, it is decay, like number 1, because 0.4 is between 0 and 1. So number 1 is going to be decay. And if it asked us how much it has decayed, it would be 60%, because it's the difference between the 0.4 and the whole. On question number 2, 3/2 is greater than 1, which means it is going to be growth. And if it asked us how much growth it would be, what percentage of growth, 1.5 means there would be 50% growth. Now, if you notice on the next two, the base is E on those. So if you notice, here's a base of E, and here's a base of E. When we're looking at a base of E, in order to decide exponential growth or exponential decay, we look at the exponent. And in this case, our exponent is positive, which means this is going to be growth. And on this one over here, our exponent is negative, which means it is going to be decay. Okay, simplifying these exponents, we did this in the last chapter last semester also, so we just need to remember our exponent rules. So if we have a 4 here on the outside, it needs to go to everything on the inside. So we're going to have 2 to the 4th power. E, inside, outside the parentheses we multiply, which is negative 20x. And the important thing to remember here is that when you have a negative exponent, we can't have answers with negative exponents, so we need to move that to the bottom. 2 to the 4th power is 16, and we're going to move that e to the 20x to the denominator, so e moves down with it, and the exponent of 20x goes into the denominator. On number 6, I'm just going to get a fraction bar here, 5/10. 5/10 there is going to simplify to 1/2. And e to the 11th divided by e to the 14th is e to the negative 3. So to make that e positive, I'm going to put that e to the 3rd down in the denominator. Okay, then here on 7, 8, 9, and 10, we have, it tells us the values of a couple of logs, and we need to use that information without a calculator other than just adding and subtracting decimals. So we have log base 4 of 11 divided by 5. That is like saying log base 4, if we break that apart, log base 4 of 11 minus log base 4 of 5. Because remember, when we have division like that, it means when we expand it out, it means subtraction. So that means we're going to subtract our value for log base 4 of 11, which is 1.7297. And we are going to subtract 1.161 to get let's do a different color, 0.5687. Okay, and then we're going to kind of think of that same thought process here for number 8. 55 could be rewritten as 11 times 5. That's 55. And when we have multiplication, when we break that apart, we use addition. So we would have log base 4 of 11 plus log base 4 of 5. So we're just going to add those two values together. So we would have 1.161 plus 1.7297 to get 2.8907. Okay. Here we have on 9 and 10, we're going to do some condensing this time. Subtraction here in the middle tells us we need to divide. So we're going to have log base 4 of 22 divided by 2. Because subtraction means division. 22 divided by 2 is just 11. So that's just going to be log base 4 of 11, which we know is 1.7297. On question number 10, on the paper that you have, it had a 6 right there instead of a 5. It should have been a 5. So if you're watching this video and didn't hear me say that in class, that 6 should have been a 5. So if we are going to condense log base 4 of 5 plus log base 4 of 10, we would get 5 times 10 is 50. So we would have, let's see here, we would have log base 4 of 50 minus log base 4 of 2. Well, now if we condense it back together a little bit more, we would have log base 4 of 50 divided by 2, which is just log base 4 of 25. 25 can be written as 5 squared, which is just 2 times the log base 4 of 5. Because remember, with that 5 squared, we take that exponent and move it out to the front. So we're just going to double 1.161 times 2, which is, sorry about the mess there, in blue here I'll write down what we should get. We should get 2.322. Okay, so now we're actually going to do that expanding and condensing of logs with variables instead of just numbers. So if we have the natural log of x divided by the natural log of 3y, the first thing we're going to do is break that apart just a little bit. We're going to remember division means subtraction, so we're going to have the natural log of x minus the natural log of 3y. Well, we still have this 3 times y that we need to deal with. So we're going to have the didn't mean to do that. So we're going to have the natural log of x minus, and remember when we're subtracting both of those pieces, we need to put it in parentheses, so we'd have the natural log of 3 plus the natural log of y. When we break apart that 3y, we break it apart with addition. So we have the natural log of x minus all of that. If you distributed the negative through, you'd have the natural log of x minus the natural log of 3 minus the natural log of y. Same answer. Okay, so then we have log 10x to the 5th. If we break apart first, we would get log of 10 plus log of x to the 5th. Can't have that exponent in there if we are expanding it out, so we're going to take that, we're going to have log of 10 plus, we're going to move that 5 out into the front, 5 times the log of x. Okay, 17 here. All right, this time we are condensing them back together. I know we need to condense them back together because there's 2 terms here that need to be put back together. If I have a 2 out in front, the first thing I need to do is take care of that and make it into an exponent. So I'm going to have log base 7 of x squared, because I'm going to move that up, plus log base 7 of 11. And with addition, I'm just going to put that together with multiplication. So I'd have log base 7 of 11x squared. Okay, let's see here. Isn't there one more? Yes, there is one more here. All right, this one has 3 terms, so we're just going to go one thing at a time here. I'm going to move those exponents up first. So I'm going to have the natural log of 2 to the 5th. 2 to the 5th is 32, plus the natural log of x to the 7th, plus the natural log of y to the 4th. Then, since these are all addition here, I can put it together with multiplication. So I'd have the natural log of 32 x to the 7th, y to the 4th. Okay, here on the back page we have the hammerhead shark question. It gives us the equation and it tells us how long the shark actually is. So we are just going to substitute that length in for L. So I'm going to say 175 equals, I'm just putting that in there, 266 minus 219 e to the negative 0.05 t. Okay, so then I'm going to subtract 266 from both sides, and I get negative 91 equals negative 219 e to the negative 0.05 t. Then I need to divide out that negative 219. We want to make sure that when we divide those two numbers that we at least get 4 decimal places past. So I have 0.4155 when I divide. equals e to the 0.05t, or excuse me, negative 0.05t. And to get rid of that e, remember we use natural log, so I'm going to take the natural log of both sides. And when I do that, that gets rid of my e, so I'm going to have the natural log of 0.4155 equals, that gets rid of my e there, 0.05t, or excuse me, negative 0.05t. When I put that into the calculator, I'm going to put in the natural log of 0.4155, make sure you close that parentheses, and then divide it by negative 0.05, and you should get approximately 17.5. So the shark is approximately 17.5 years old. Okay, as we look at a few of these here, I'm going to kind of do it like we did in class the other day. I look at the first two questions. I notice a couple of things. First of all, I have natural log on both sides of the equal sign. I have log base 2 on both sides of the equal sign, which means as long as I have the same log and the same base on both sides, I can just set them equal to each other. So I can say 3x minus 9 equals 2x plus 6. And just a little basic algebra, I'm going to subtract my 2x from both sides. X minus 9 equals 6. If I add 9 to both sides, I get x equals 15. Okay, same basic idea over here on question number 21. Since I have log base 2 and log base 2, I can say that 3x minus 4 equals 5. If I add 4 to both sides, I get 3x equals 9. And x equals 3. Okay, this one is a little bit different. We need to condense this first. We have two logs on the same side of the equal sign, which means in order to condense them, it's addition, which means I'm going to multiply. So I'm going to have log base 6, that stays the same, and I'm going to multiply these two together and get 3x squared minus 3x equals 3. Lots of 3's in there. Okay, now I notice I have a log on one side and a number on the other, which means in order to solve this, I'm going to need to rewrite it as an exponent. So I need to take my base to my power. So I'm going to have 6 to the third equals 3x squared minus 3x. 6 to the third power is 216. And in order to make my numbers a little bit smaller, I'm going to divide out a 3 out of everything. So I get, kind of running out of room here, I'm going to go in a different color so you can see where I'm at. 72, because 216 divided by 3 is 72. X squared equals x squared minus x. And if you subtracted that 216 over first and then divided by 3, you should get the same thing. Because we know that ultimately we want to have it set equal to 0. So I'm going to subtract 72 now from both sides, and I get 0 equals x squared minus x minus 72. When I factor that, I'm going to get x minus 9 and x plus 8, which set equal to 0, either get x equals 9 or x equals negative 8. Anytime we get two solutions, we want to double check. And if I notice when I put negative 8 back into the original equation, it makes my logs negative. So I can say that that is an extraneous solution, and x equals 9 is my answer. On question number 23, if you notice, there is only log base 5 of something on one side. It's nothing that we need to condense or anything yet, because there's only one log on one side of the equation, which means if we need to solve this, we can't just set anything equal to each other just yet. We need to rewrite it as a exponent. So I'm going to say 5 to the fourth equals 5x plus 10. Again, this is just rewriting as exponents. 5 to the fourth power is 625. And then everything else is just some basic algebra. I'm going to subtract 10 from both sides and divide by 5. So I get 615 equals 5x. X equals 123. Okay, let's see these last few problems down here. this question number 24, you're hopefully looking at it saying, oh, I know how to do that. That's really easy. My bases are the same, so I can just set my exponents equal to each other. So I can say that 2x equals 3x minus 1. I can subtract and get my x's on the same side, and I get negative x equals negative 1, so x equals positive 1. Question 25, we have, it's written as an exponent. There's not an exponent for the 7 that we can just set anything equal to. If we have it written as an exponent and we need to solve it, we need to rewrite it as a log. So we're going to have log base 3 of 7 equals x. And you can go ahead and put that into your calculator. And we put log base 3 of 7 into your calculator, that you get that x equals approximately 1.77. All right, and last but not least, we do not have like bases. However, hopefully you notice that it would be really easy to get like bases here. So we would have 5 to the x minus 3 equals 5 squared to the x minus 5. So I would have 5 to the x minus 3 equals, inside outside means I'm going to multiply 5 to the 2x minus 10. Now my bases are the same. So now I can just set my exponents equal to each other and say x minus 3 equals 2x minus 10. And if I subtract x from both sides, I get negative 3 equals x minus 10. If I add 10 to both sides, I get x equals 7. And there you have it. I hope everybody does well on the test tomorrow. Good luck.